It's me again for another Ology video. So yeah, following on from yesterday's video of astrology, we are now going to be talking about cosmology and what cosmology is all about. So yeah, cosmology is a science of the origin of the development of the universe, and modern cosmology is dominated by the theory that we probably all know by now, the Big Bang theory. And it brings together observational astronomy and particle physics, and is an account of or theory of the origin of the universe. So yeah, it's a mid-17th century word from the French word cosmology, or modern Latin word of cosmologia, and it comes from the Greek word of cosmos, spelled with a K instead of C, as cosmology is spelled with a C, and the Greek word of cosmos is spelled with a K, and cosmos means order or world, and logia means discourse and all that. And it's cosmology is a branch of astronomy that involves the origin and evolution of the universe, from the Big Bang theory from the Big Bang to today, and we'll possibly go into the future. My tablet is trying to tell me something. And according to NASA, the definition of cosmology is a scientific study of the large-scale properties of universities. Not universities. I'm used to saying universities or not. The scientific study of the large-scale properties of the universe as a whole. Now, cosmology is like a puzzle of concepts, like a string of theories, dark matter and dark energy, and whether there is one universe or many. Sometimes called sometimes called a multiverse, and where other aspects of astronomy deal with individual objects and phenomena, or collections of objects. Cosmology spans the entire universe, from birth to death, and the wealth of mysteries at every stage. Our understanding of the universe has evolved significantly over time, and in the early histories of astronomy, Earth was regarded as the centre of everything, with planets and stars orbiting us. In the 16th century, Polish scientist Copernicus suggested that Earth and other planets in the solar system, in fact our solar system, orbited the Sun, creating a profound shift in the understanding of the cosmos in the late 17th century. Sir Isaac Newton calculated how the forces between the planets, specifically the gravitational forces and their interactions. And my brother's banging out his rubbish tunes. And at the dawn of the 20th century, brought further insights into the comprehending of the vast universe, and Albert Einstein proposed the unification of space and time in his general theory of relativity. In the early 1900s, 20th century, scientists were debating whether the Milky Way contained the whole universe within its span, or it was just one collection of many stars. And Edwin Hubble calculated the distance to a fuzzy nebulous object in the sky and determined that it lay outside the Milky Way, by proving our galaxy to be a small drop in the enormous, what would become the larger universe. And using general relativity to lay the framework, Hubble measured other galaxies and determined that they were rushing away from us, leading him to conclude that the universe was not static, but static being immobile, like a kind of like a house, kind of like the usual house, but in fact expanding. Now kind of a bit like a caravan. And in recent decades, the cosmologist, a late cosmologist Stephen Hawking, rest in peace, determined that the universe itself was not infinite but has a definite size. However, it does lack a definite boundary of where it all stops and all. And it's kind of like similar to the Earth, so like although the planet is finite, a person travelling the world will never find an end, but instead constantly circle the globe. And Hawking proposed that the universe would not continue on forever, but would eventually end. So we all hope. And it's like, and in the past, like people have tried to kind of come up with answers, and in like November of 1989, NASA's Cosmic Background Explorer (COBE) took precise measurements of radiation across the sky, and the mission operated until 1993. And although NASA's Hubble Space Telescope is probably best known for its like amazing pictures and all, the primary mission was a cosmological one. And I kind of struggle with all the logical words, like cosmological. But as Hubble more accurately measured the distance to Cepheid variable stars, with a well-defined ratio between their brightness and their pulsation, Hubble helped to refine measurements regarding the universe, how the universe is expanding. And since the launch, astronomers have continued to use Hubble to make cosmological measurements and refine the existing ones, and thanks to Hubble, cosmologist Adam Rose might have a job. As I said, if you put a box in a way that dark energy might differ from the cosmological constant, that box would now be 3 times smaller. That's progress, but we still have a long way to go to pin down the nature of dark energy, and that's him on his and like NASA's Wilkinson microwave anisotropy probe, WMAP, was a spacecraft operated from 2001 to 2010. WMAP mapped the tiny fluctuations in cosmic microwave background. CMB, ancient light from the early universe, and determined that ordinary atoms made up only about 4.6% of the universe, while dark matter makes up about 24%. So there's a lot of it out there. And like cosmologist Charlie Sethi in the journal Science said, lingering doubts about the existence of dark energy in the composition of the universe itself when the WMAP satellite took the most detailed picture of the cosmic microwave background. I think some noise, I think. Now in the European Space Agency's Planck, spelled PLANCK, space mission, ran from 2009 to 2013, continued the study of cosmic microwave background. And the ESA and you can kind of show us in the European Space Agency, so ESA, and the ESA is currently developing the Euclid mission, which should fly by the end of this decade, which shouldn't isn't too long thinking about it. This year and next year. And it clear, lucid. We'll study like the dark matter and dark energy with greater precision, tracing its distribution and evolution in the universe. Like at the heart of the mission is one of the billion-pound questions of physics. It's like a statement made by ESA's David Parker. And it's like, and because of like the enclosed and finite nature of the universe, we can't see the outside of our own universe. Like space and time is thought to have began with like the Big Bang, as some people might beg to differ about that. But I know not everyone believes in like the Big Bang. There's no way to. That's why there's many speculations about the existence of other universes, and there's no practical way of observing them yet. And as such, there will never be evidence for or against them yet.
Yeah.
And it's like, many people think that perhaps the Big Bang itself didn't happen out of a single point, but was the appearance of space and time throughout the entire universe at once. And if we travel to a distant galaxy, it would seem that all surrounding galaxies were similarly rushing away. That's for everyone to know. Anyways, it's kind of like think of it as a balloon kind of thing, and if you kind of pace it at many points, you would know that each point would be moving away from the others, although none are at the centre. The expansion of the universe essentially functions in much the same way as that. And like cosmologists have revealed data by like the Planck team in 2013 that the universe could be as old as like 13.8 billion. As old as like 13.8 billion years old. It will take 100 million years, and it's kind of like give or take 100 million years or so. And it's like kind of determining age using like cosmic microwave background and like the fluctuations in temperature, as small as they may be. And it's like, as Charles Lawrence said, who is part of the US project scientist for Planck, in a statement, patterns over huge patches of sky tell us about what was happening in the tiniest of scales in the moments just before our universe was born. And it's like, some of the people now are looking to and asking, when will the universe end? Will the universe end, and if so, how? And it's like, it's not whether or not the universe will end depend on its destiny, as it's essentially theoretical at the moment and no one really knows the answer. And like how spread out the matter might be within it. And it's like scientists have calculated a critical density for the universe. If its destiny is greater than their calculations, eventually the expansion of the universe will slow and then ultimately reverse until it collapses. And it's like, what if the density is less than a critical density? The universe will continue to expand forever, or so they think. And it's like, when post-Big Bang universe was composed predominantly of hydrogen with a little bit of helium thrown in for good measure. And like the gravity caused by the hydrogen collapsed inwards, forming structures. And like, however, astronomers are uncertain whether the first massive blobs formed individual stars that later fell together like via gravity, or the mass came together in like the galaxy, in galaxy-sized clumps that later fall on these stars, and like I think from what I remember from this, like the stars kind of collapse under its own weight eventually when everything kind of runs out and releases like a whole load of other elements beyond helium and hydrogen. And yeah, from there planets and all that can be formed. So yeah, from there, the like solar systems like our own little tiny patch can form. So yeah, this is today's video, and I'll see you all very soon. And I'll see you on Monday for another Cosmology video, and very soon for the news.